presenter is Pierre Feillet, who is one of the key people behind IBM Artificial Intelligence for decision automation. Last year, Pierre presented IBM AI advances in the decision intelligence, and today we will hear about the latest developments, about their progress, and Pierre probably is the best person to present it. And IBM, of course, is the largest vendor in this area, and everybody looking forward to hear your presentation. Pierre, please take over.
Thank you, Jacob. So yes, let's share with you what we are doing at IBM and let's say the perspective about agentic decision intelligence. So I am chief architect at IBM at the IBM France lab. So the agenda for this lecture, for this session, in three parts. So where we are, what we have accomplished so far in the decision automation domain, and what is in front of us with generative AI. Generative AI is, let's say, with us about 4 years now, and with an acceleration with generative AI agents, and new approaches are now possible. And the third part of this presentation will be about to get it right. So how can we combine the, let's say, all the technologies and methodologies to have the productivity gains thanks to generative AI, while keeping the key, let's say, advantages that we are looking for to automate businesses. So first, congratulations to this group. Business automation already works. And 4 years, we have automated businesses in banking, insurance, claim processing, you name it, with technologies like business rules and reinference, optimizations, constraints, so forth. And with a kind of waterfall or classical pipeline of development, starting from business policies. And usually what we have done is we have access to SMEs. So we have complete or incomplete business policies. We dialogue with SMEs. And we capture, we translate the know-how into decision models. And we can loop, okay, to have better coverage, to improve the decision models. And at some point in time, after testing, simulation, promotion from dev to prod, we execute, and we can execute at scale as decisions. And thanks to these decisions, we obtain business outcomes that may be captured less or more, depending on the organizations and the IT. And in the best cases, we can apply analytics to better understand the efficiency of the decision automation, to possibly go back to the decision models and go back to the soft piece of the business policies when this is, let's say, something that is local to the enterprise and not about the regulation. So this pipeline is already in place with many projects in productions, with rules or with classical programming models. But so there is a mic open. And what we are looking for usually is trust, determinism in this high-stake decisions, and explainability, traceability. And to be good, so we have to offer a governance for the execution, especially for the large volumes and real-time decisioning. We have to operate, we have to execute in milliseconds. And with technologies like Java and rule inference engines, we can do it already. So we are matching, let's say, the expectations of the market, and the same for the low operational cost compared, by example, to the cost of operating a large language model in terms of tokens and response time. We are not in the same space. So execution is already excellent, but gap remains in the, let's say, how to have access to the business expertise and to translate the business requirements or the business policies into formal models. And this is where it's difficult because you have to have access to the SMEs because it's a kind of art to translate the natural language documents or discussions with experts into formal models. And for the post execution, there is expertise as well to understand how you will judge what will be the KPI, the metrics, and in what time span you will have feedback to possibly optimize when it's possible your decision making. So in a nutshell, the bottleneck is not running the decision, but this is building them. And what we can observe is that if the run of the decision services or the rules or the other artifacts that can be into play for this automation, the execution is okay. The capture of the translation from natural language information or text to formal models remains, let's say, slow because this is at a human pace and this is manual. And for the analytics about the decisions that have been made, this is the same, let's say, caveat. And you need to have manual review and expertise, and this is not at machine speed. So we could see that we want to have to accelerate this life cycle, this pipeline, and minimize, let's say, the steps or the phases in which we are purely manual, and we need a great time of SMEs, and the SMEs are, let's say, time is rare in the organizations. In addition, so we see, and Jacob, so you mentioned transformation of the DecisionCAMP website thanks to a coding agent. So coding through Agentic AI is more and more popular. And the build versus buy equilibrium is changing. So it has been stable for decades with some evolutions with 4GL or IDEs and let's say tools. But with coding agents, we see a significant acceleration in the ease and the reduction of time to have a web app or to have a decision service that can be generated by an agent. So we have to consider this in the way we build decision platforms in the options that clients or all players can have, let's say, have to generate or to make a new decision automation in their organization as well. So the challenge is engineering and evolution, not execution. And there is a will, let's say, to benefit from more machine speed while we want to keep trust and the key qualities that we are looking for the decision automation. Here you see an old map in the US with the rates of travel 2 centuries ago. And you see in weeks the times that you would have to spend to travel in the US. So we can observe that there was an acceleration. And because of the technology, steam and rail. And coming from this, we can see today and we can anticipate an acceleration or a change in the time, in the space-time for the software industry. Meaning that the generation or the even, let's say, not only the code generation, but the testing, the packaging, the deployment. So many aspects of the software factory are changing thanks to generative AI. And we can apply this to decision automation as well in the capture of the knowledge. So even if we cannot claim that it will be, this is already perfect and it will be perfect in 2 years, this is a game changer, and we see, let's say, acceleration in this space. The way we can manage a specification or, for example, detect gaps between what you see in or what you understand in a policy and what you can capture in the specifications that you can generate and validate through a human intervention. The testing and simulation, and so forth. So there are many aspects in the decision automation life cycles that can benefit from this space-time change and acceleration thanks to generative AI and Agentic. Some kind of recall, because in some communications, there is a mix between concepts, and I think that it would be good, let's say, to agree on the definitions or some definitions of these concepts. If it's not the case, we can let's say discuss at the end of this lecture. But between data, information, knowledge, and adding wisdom on the top. And because so often they are mixed together, and we are losing track, let's say, of the differences. So data, so to me, this is raw and uninterpreted facts, so like numbers, records, timestamps. And information is, let's say, adds value on the top of the data, because we are adding organization with the context. Okay, so in this case, answers who, what, when. And we can have a filtering to discard, for example, data that are erroneous or that are out of context, and so on. So there is a filtering between information and data. Data, this is just raw stuff. Knowledge, this is a level on the top of information, because I understand, I see causal understanding added on the top of the information. So and this is to support judgment and action. So an if then else or something, let's say, with a kind of causal row between pieces of information. And this is what we exchange, or when we discussed with an SME, usually we are dealing at this level, or we are dealing in addition to, let's say, at the wisdom level. So this is about knowledge applied with judgment, and knowing when, why, and how to act, including the exceptions. So this is very common in the projects deployed in organizations, but it's rather easy to deal with the common case. And after, it's much harder to understand all the exceptions and how to categorize the exceptions and to deal gracefully with all the cases. And these exceptions may not be captured in a policy or in a full, let's say, full text document. You have to discuss with the SME. And when we are dealing with, when we are automating decisions, we are not only dealing with data or information, we have to be good at knowledge engineering and at the wisdom level, if possible. So knowledge engineering, right now, with the Agentic and the generative AI wave, I consider that it gets rebooted, but not reinvented. So I see, let's say, newcomers or new players in this domain who find out that knowledge is key on the top of what can be generated by a large language model, and that see with interest, it would be good to have a graph of concept, or it would be good to have an ontology. And ontologies, taxonomies, standards like OWL and RDF, expert systems. So they have been around for a while, and we can use them. If you can mute yourself, please. And we can use these concepts and technologies and mix them with generative AI today. Back to the element of on the extraction and the translation from business policies into formal assets. So the big opportunity today is to take advantage of the generative AI, and so that can be packaged and operated through agents to help in the capture of the knowledge from plain text documents. So from PDF or from documents with graphs and schemas. So today we can do some things that was just out of scope and even in research 5 years ago. And this is a kind of summer of AI, and this is good. But it means that we have to reconsider, let's say, some options and opportunities in the way we are automating decisions for the enterprises. One aspect that remains, this is not only the capture of a V1 and with a policy that is perfect, but how we can perform a good decision automation with an incomplete policy, or let's say with something that is not precise enough. And so you have to interpret, but you have to challenge the policy to have a good enough formal decision model. And the maintenance. So when something changes in the requirements or in the policy or in the intermediate specification, the decision automation platform has to be good to manage or to help in this maintenance. So reasoning models don't replace knowledge engineering. They remove or they reduce the cost for this bottleneck, the manual acquisition, and there are opportunities to do a better job now. A topic that has been addressed one year ago and with Harley from Athena company is that why not directly automate your decisions with a large language model and a reasoning model? And very quickly, so in the decision automation for enterprises, we are expecting usually determinism, low latency, governance, low cost, and precision. While reasoning models, they are good in the understanding or some form of understanding, some form of reasoning and adaptability, but they are not matching, let's say, all the key criteria that I see to automate decisions for organizations. We can debate at the end after. And I see a kind of intersection or opportunity zone with agentic engineering and hybrid AI by mixing different technologies, typically rules and generative AI, but it can be optimization as well. So going a little more in depth in the agentic perspective. So we have already done experiments. I think that so most of you have experimented to automate decisions or to generate code to automate decisions and so forth with multi-purpose assistants like ChatGPT or any copilots. But if we want to be good at the enterprise level, it has to be better than just use Claude or ChatGPT. Because we want to have the determinism and some governance, some traceability in the way we work from the policy to the operated decisions, and after how we post-process with, let's say, all the qualities that are expected by enterprises. So I will not go, let's say, in all the details because time flies, but the one central idea on this slide is I think that we have to change the scope of the decision automation platforms and start from the policies and treat specifications and policies as first-class citizens, and not only start from DMN models. We have to start from natural language assets, and this is very new, and this is thanks to generative AI. There is a real advantage. And the last bullet on the right side, one of the challenge is to calibrate the autonomy of this agentic decision intelligence in a good way, to keep trust, to have human validations, not too much, not too, let's say, too little, to make sure that we have the productivity and the trust. What we have seen in the so around not only in the decision automation domain, but there is more and more specification-driven development, and we can apply it to business automation. So the idea is to start from a policy, you extract the knowledge, you can have your business specification. You will have multiple AI agents, so that can be specialized about the modeling, about the testing, the simulation, do some critique or challenge the models that you have starting from the policy, and obtain the decision assets, and with all the criteria met about the determinism, precision, and so forth. Back to Marvin Minsky, the Society of Mind. So I propose a society of specialized agents, and it's just an example. We can imagine other societies. So we can imagine in this society of agents for decision automation or decision agents, policy agents that understand the policy and that will parse, that will analyze, extract clauses from this policy in natural language, raise ambiguity flags. So when there is something that is not, let's say, that looks not logical in the text, or that is too open to interpretation. So I think that there is an interest to analyze and to challenge the policy and do it through an agent. The knowledge agent, it would be connected to this first policy agent to go further in making the ontology, extract entities, and ground all the concepts and the relations that will be detected from the policy. And after, we can continue in the modeling, the simulation, an optimization when we have a cost function or a profit function that has been expressed along the decision service outside of the logic to automate something that we want to minimize or maximize. And the governance, so governance remains key. Even if you are introducing agents, you have to control, you have to orchestrate, and you have to make sure that with the role-based access, humans, let's say, are in the loop and are checking what has been proposed and possibly automated by agents. And the monitoring and improvement, and this is post, let's say, execution. You have to see, let's say, if you are deploying a V2 of your decision service, you have to make sure that there is no drift for example, in the proportion of loan approvals that has been loan applications that have been approved or rejected, or if it's the case, this is something that was expected, but not a surprise. So the monitoring remains a kind of usual need. What we had, this year we have progressed on some very tactical aspects in the IBM decision intelligence portfolio. Super quickly, so this is very common here to develop MCP servers and even generate an MCP server on the top of REST API. So we have done MCP servers for the DI product and for ODM. But so you name it. I think this is a kind of standard de facto to offer MCP servers that can act locally or remotely, and that can be consumed by agents. So this is a kind of underlayer aspect of the agents that are using MCP servers to act on different microservices and assets. And what we have done in IBM this year is we have continued to develop a decision assistant that is now multi-turn. And now you can ask anything to this assistant, for example, to critique a decision service, to ask to create or to test suites, and the results are positive. Even if we can always, let's say, improve what can be done, or some aspects in the way the generative AI answer, but definitely there will be no turn back, and the agentic wave is has started. Quickly. So I see a kind of disruptive progress with generative AI, and even just MCP, there is a kind of disruption in the way we can orchestrate and integrate layers of software with a kind of soft integration. No more with a rigid contract, but with an interchange and a calling that is made through natural language and through reasoning or large language model. And this is changing the game. So few examples specific to decision automation here. So for the knowledge extraction, so I am not here yet, but we can anticipate that today, or let's say next future, that it will be super easy to extract from 100 pages or more of policy and regulations expressed in PDF documents. To have a nice ontology and proposed by a knowledge agent, and that we will see at the end the rules grounded from, let's say, to the source. And we have already something, let's say, like this with let's say less volume today in IBM, but that goes in this direction. The formalization, this is something that is let's say quite hard, but we see, let's say, progress as well with generative AI to generate decision model, generate rules, decision tables, and not just prose, but something formal, and something formal that we can test. So there is a kind of particularity in decision automation that when you reach these formal models, you can test them, and you can, based on the behavior of the asset, check back to the policy or to facts or the suites that you may have, if they are matching the expectations or not. Test case generation. So this one is rather easy, and just with the MCP or on the top of any rule engine, it's rather, let's say, easy to generate test cases. And at IBM, we can do it with Bob, but you can choose your coding agent as you wish. What if in natural language? This is one of the opportunities, and it works, let's say, pretty well in some cases already, but we can anticipate progress in this analytics and conversational platform interaction. So I select the last. The one aspect in when you start to have an assistant is that you have to rethink your UX. And this is not adding a chat UI inside your existing UI. You have to progressively change the overall UI and UX. And I think that there is a trend to have a chat UI as a kind of central piece of your UX, and have specialized panel and components when the chat is not enough. but I see let's say an increasing importance of the chat UI. And have some satellite UI around it, but no more kind of addition of a small assistant in addition to a classical UI. I think that we are evolving from there. In this AI native PDLC, I see 3 levels or 3 loops. So speed is a kind of top priority. I think in this in the software industry and larger. So, and with generative AI, we have to speed up the engineering loop. So with going from policy document, natural language, unstructured information, to capture knowledge, to write specifications, have a human in the loop to validate the specifications, and to formalize decision assets. The execution loop, it remains quite classical. So at some point you have a decision engine, you run it, and you have operational decisions. And for the learning loop, so compute KPIs, so metric KPIs, you can, in addition, do simulations, what if, and come with recommendations. This piece is not new, but with agents, you can do it with, let's say, less coding to write manually, and with more efficiency, let's say, to provide a platform to have this learning in place. In all cases, so AI accelerates, so in my opinion, the understanding, the engineering, the simulation, optimization, and other aspects. But you need to have a human in the loop. Okay, so the interpretation of a policy, it remains hard. If you are in the medical domain, or if you are in I don't know, legal, let's say to decide at a border if we accept good or not. There are plenty of aspects that need some common sense or that need expertise, and the human, let's say, remains required. The generation of the assets, so it's good to have them generated, but you have to keep an expert in the loop to make sure that you are not missing something in the translation or the extraction of the knowledge, and in the formalization to have decision assets as expected in your technical platform with the execution of the behavior that you expect. So it remains, let's say, you need a human validation for this deployment. I would say less, but you need. So let's say you continue to have a kind of human go to say, okay, we are good. We are triggering the move to production. Otherwise, you can be, let's say, more optimistic and say that you automatically let's say deploy something if the test suites are running okay. But I know clients that may not let's say adopt this level of risk. I would say it depends. And overall, the governance it has to be I would say human-centric with acceleration thanks to agents. But the final decision to do something or to let's say remains human, and because the responsibility remains human and taken by teams, not by agents. Quickly, so from what we have seen about for 10 years in data science, with a good concept that is data lineage, to understand, let's say, the source and the transformation of data to build machine learning models. I think that there is a decision lineage as well. So it's about the justification and the improvement. So the justification, this is looking backward from any execution. And so we have taken this decision. So what was the decision logic, the decision model, why we have made this decision model, it was because of this specification. Why we had this specification? Because we interpret like this policy, and the policy is in V1 or V2. And for looking forward, it connects the same execution to business impact, and we have to be good to capture all the information that are parallel or connected to the decision to figure out if the decision, the automation was good or not. And this is not only, let's say, in terms of software, but have we blocked valid transaction, or have we authorized a transaction that was in fact fraudulent? We have to understand this and to improve, and for the software, but for the business knowledge as well, to have a better automation. This one super quickly. The point here is that we have to treat the policies and specification as first-class citizens in the decision automation or decision intelligence platforms. So we should not just start from decision models or rules or ontologies, but from natural language documents. And it means too that we have to keep them in sync. So if the policy is changing, it should trigger an ask for change of the automation. And if at some point we get good feedbacks to say, okay, there is something suboptimal or something where we see that the decisions that has been taken are not efficient, we should trigger at minimum a question or an action to modify the specification and to have a business analyst in the loop. As a kind of recap, so no time to show it in an IBM product, but on a loan approval, in this agentic, let's say, pipeline, we are starting from the policy. We are doing the extraction with agents and with structure. So we are starting from information to knowledge, or natural language knowledge to formal knowledge. At some point, we are generating rules, constraints, so logical pieces that are formal, that we can, and we have a loop here with a validation by human plus agents. We execute at scale, and we monitor and we improve, but we are not improving, let's say, automatically. We are doing recommendations. And sorry. We have a human. Yes.
A quick question here. Last year, when you talked about generation rules, you mentioned that you working on generation of decision tables. You already do this?
Decision tables right now in decision intelligence, we don't do it. We could. We have, let's say, all the underlying APIs to do it, but we have chosen other, let's say, priorities in the development. Today, we are generating decision models. So I would say everything outside of decision tables. So decision models, operations with the signatures, a data model that is fully typed, in each decision node, list of rules, and the nodes are connected, and we can generate test cases. So this is, let's say two levels to answer to your question, Jacob. We in the DI assistant, you have two modes, and there is a mode in which you discover and you start from the policy. Okay, so in this mode, you are generating rules, but not decision tables. After, you can continue the conversation in what we call the multi-turn conversation, and here you can create other assets like decision tables. So if you express a kind of a piece of specification to say, I want to do a decision table with given my conditions with values like this, and my actions will be, for example, to set a grade. In the assistant, we will produce a decision table that will be added to the decision model. So basically, the answer is yes. Does it answer to your question, Jacob?
Yes, go ahead. Thank you.
Research challenges that I see ahead. So in the understanding of policy, if there is always place to interpretation, and this is something that we cannot claim, let's say, perfect. So in the reasoning models or in the way we instruct them, in the way we do agents to wrap one of several reasoning models. I think there is a space to improve in this understanding. The specification as well. So I would say that today, if so we generate, for example, in DI assets. So as mentioned, Jacob, on the decision model, the rules, and so forth. But to be sure that the formal assets are always, let's say, valid. This is a challenge, especially when you are dealing with domain-specific languages. Because the language is always, let's say, specific to a domain. This is not like generating Java. This is a little more complicated. So the verification of the formal assets and of the specification, we have to do progress. But I am optimistic. Collaboration across agents, so the multi-agent research community has worked on this for dozens of years. I think that there is a space to improve and to do research as well. Going quickly, governance, it remains key, and it's no more governance across only humans, but governance with a mix of agents and humans. And I think that there is something, let's say, to invent or to improve and make sure that we have the right level of autonomy with the agents. This is my number 6. And the evaluation, when we are dealing with assistants or agents, it's not trivial to measure their efficiency. So, for example, if you are looking at an agent that discover rules from a natural language text, how you will judge that the extraction, let's say, went well. About the coverage, about the precision, how do you compare that two different extractions, or if you generate a fully decision model, how you will judge them. One is one better than the other? Is there a kind of inclusion, or we could even think about an algebra to compare and to manipulate the generated asset? But this is another topic here. And in the collaboration between agents and humans, we need to have a kind of common ground. So we see today proposals around wikis and MD. I go quick, but we need a kind of memory to support this collaboration. So as a recap, I see a future of business decisioning with agents, that are in the center of the decision intelligent platforms, and in the center of how we build the platforms. There are 2 levels: the way we develop these platforms and the way these platforms will be used by clients. And the overall idea is this is not to replace trusted execution with a generative AI, just use a large language model and to automate decisions. Honestly, I don't think that it will fly. But this is transforming the entire engineering life cycle into a specification-driven and a knowledge-centric approach to capture, let's say, the knowledge and to improve based on the outcomes of the decisions. And to finish on this, so this is about. So I continue to go in the, let's say, to support an hybrid AI approach. for decision automation and business automation as well. So you will see a list of references, and you will have the links on the IBM Decision Intelligence products and ODM coming from iLog Rules, and there are other readings that are proposed as well. So thanks for your listening, and I am open to questions.
Thank you, Pierre. Questions? You can just unmute yourself or raise hand or do it in our chat. Okay. Okay, well, people think, and I will ask you a question about ontologies. This is, I don't remember, you did this before, but recently Professor Frank Coyle from US Berkeley published very interesting presentation about the integration of agents and the ontology, when ontology actually replaces guardrails. And
Yes.
he also provides, like you mentioned, 3 loops, and he provides very specific loop, and probably many people follow this approach. Do you have anything particular experience that you can share with some links where you use ontologies together with Agentic AI?
So today in the IBM products, we have a kind of ontology. So I will not claim it as a, let's say, full standard ontology, but we have a data model with all the relationships between concepts and all the attributes. And we separate from this data model the logic that is already captured in the decision model. So this is the way we operationalized the knowledge engineering from G-Rules. On the let's say on larger ontology, I don't have, let's say, more to say, Jacob. But on the paper, and I don't know, I can find it later. But there was a paper recently, I think, at Microsoft, benchmarking different LLMs and showing that for complex tasks, the LLM was let's say limited, but the big difference was about to wrap the LLM in a kind of harness, and in the harness you can have rules and to guide and to, let's say, the kind of meta reasoning, if you want, of the reasoning model. And I don't know if it goes in the same direction, but I think that this is something that we could look at, let's say, with attention in the next months.
Okay, good. Because it looks like integration with ontology still in research mainly area, and I'm really looking for some practical use of ontologies in Agentic AI environment. Okay, Paul, you have question or somebody? Go ahead with questions. Unmute yourself, Paul.
Yes, you are muted.
You are muted.
Is that better? There we go.
Yeah.
Thank you, Jacob. Pierre, great presentation. Thank you. I was going to ask, what do you think is the importance of DMN in the sort of like future of AI generator or coexistence with deterministic decisions? Do you see that as a critical piece, or is it really just optional?
Do you want me to have a political, say, correct answer? Or?
Ignore it. Well, I guess you can give the answer from an IBM perspective and your own viewpoint as well.
Okay. So I would say that DMN is one of the standards, or the way to formalize the decision logic and the decision flow, and have everything wrapped up to model the evaluation of the decision making. It's rather easy to generate. So in the IBM let's say product scope, I don't know after, but to generate a decision model with a reasoning model or large language model. And so somehow this is a good citizen. After the more challenging aspect in the generation is the generation of the rules, especially if you have, I don't know, time reasoning or some specificities. And here it's a little harder. But I would say that DMN is not. I would not find it as plus or minus. We can generate, for example, in the IBM product, a rule flow in the JRules, let's say, style. And this is another way to organize the logic, but it works as well.
Okay, and if I can quickly just follow up as well, do you see a role for rule engine inferencing, basically to coexist with the AI generation of inferencing rule sets as the way forward, as a complement or alternative to standard decision tables, etc., in DMN style?
I'm not sure to understand your question because I have two different understandings. Please precise, Paul.
Yes, no, certainly. So the classic rule engines came from the world of logic inference, rule inference, and IBM and et cetera, and all the main classic rule engines come from the world of inference rather than simple deterministic executable decisions, and that is to some extent died out in rule-based development to some extent. But is there a possible resurgence for that as effectively to use LLMs or AI, in your view, or the IBM view, to exploit inferencing in rule engines as part of the execution of policies and specifications during decision creation?
Okay. So in IBM Decision Intelligence or ODM, classically you are writing rules or decision tables that you place into an evaluation node. So it can be a rule task or it can be a DMN node. But in both cases, you are placing the artifact that will be evaluated, and you are choosing an algorithm, typically when you have multiple rules, okay, to deal with a priority, or if you want to evaluate all the rules or the first that matches. But in my view, I don't see an opposition or big difference between a set of rules and a decision table. Maybe we could discuss, let's say,
all right,
more on this. And the way we compile a decision table and rules is very similar in the decision engine that we have at IBM.
Okay, thanks. Yeah, no, I was thinking more of the traditional sort of iLog inferencing, where basically you're programming RETI rules in a system, and that is something that is a particular skill. I know IBM. Yes. Consultants who've delivered that for large organizations, but it is a very it's a bit like Lisp programming. It's a very exquisite skill, and beyond the audience on this call, probably almost unheard of. But with the power of AI is that you can resurrect those sorts of techniques. But I was just, it wasn't part of your, research agenda. So I'm assuming it's not something that's a big priority from your perspective.
Not today, but I think that your idea, let's say, is intriguing. And yes, RETI has been popular in the expert systems area. Period. I'm sorry, but today, we see more and more the sequential algorithm used, and the RETI is less popular. But at the same time, we see inference more popular with reasoning models. And maybe at some point, there will be a kind of hybridation of stochastic inference made by a reasoning model and logical inference that can be done by an algorithm like RETI. And one of the, so it was not on my slide, but I would love to propose a mix of expert architecture for a model that would encompass an inference engine on logic and not only on the probabilistic information, but it can be for the future.
Excellent. Thank you very much indeed. Thank you.
Okay, we don't talk to IBM architects every day, so one more question, please. Nobody? So I cannot resist asking one question, Pierre. No, you never mentioned such a powerful decision engine as IBM Simplex, for example. Why?
So Simplex, okay, and this is more. So I mentioned several times constraints or optimization in the session, but I am mostly, let's say, focused on the rules and the decision aspect, but on the logic piece and not on Simplex. But I may apologize, let's say, for this, Jacob. But for Simplex, so Simplex, let's say, remains kind of a key product in this space, in the optimization space. It's good, let's say, to optimize when you have a kind of batch processing to identify, let's say, the best or let's say solutions. But so in terms of research or more, so how could I phrase it? We are working to have more fusion between the rules piece and the optimization piece, okay? Because there are opportunities, but they are not at the same time, meaning that for the timeline of the operations, the way you execute, you may not execute the Simplex engine when you execute the rules engine. So it would be maybe, let's say, upper, because so with a rule engine, for example, when you are processing banking transactions, it will be to validate or not the transactions. This is not at this moment that you will trigger a Simplex decision, a Simplex optimization. It will be much, let's say, before, when you have to allocate resources or when you will have to do choices, but for a batch or for a kind of mass processing. So it makes sense to place the optimizations and to have optimizations in the same platform, but the use case, let's say, will be subtle in the integration between rules and optimization, in my point of view. After, there are some cases where you have to reschedule. For example, you are taking a decision and you have to reschedule, for example, a planning, and then it would make sense to trigger a Simplex engine.
Okay, thank you very much for very interesting presentation, and we need to move forward.
Yeah, thanks.